Remember, our primary objective here is to learn music theory in a practical, applicable manner, one which helps us actually play our instrument. In our case, our instrument primarily being the guitar. However, the same concepts do apply to other instruments as well. In particular, we would like to learn the overarching concepts that are scalable as opposed to learning rules that are only applicable to a certain area of music, which actually then cause hurdles that we have to overcome when we are expanding our knowledge. In other words, we are attempting to learn it correctly from the start so we don't have to unlearn, but then rather can expand freely with our knowledge. To do that, we want some fundamental understanding of, in essence, the science behind sound and the pitches and what's actually happening mechanically, physically, when we interact with our instrument, when the noise from the instrument interacts with us. Last time, we had a general idea of what basically sound is, and we thought that, and we saw that, you basically need three things. You need something that the sound is coming from, such as, in our case, a string. You need a medium that it's going to travel through that we can visualize, typically as water. Comparing it to a pebble falling in water, we see ripples coming from it. In our case with sound, the medium is the air if we're in a space with an atmosphere, not in space. And then it needs a receiver, which typically is going to be the ear. That helped us to understand a little bit about some of the things that we take a priori just as is when we learn just the guitar in general, that being the notes of the guitar, which are just assigned to us, but now we see that they're actually coming from a measurable quantitative component, which helps us to understand why there are patterns that are happening when we start to list out the notes, and we understand kind of the linear nature of the notes, meaning they're kind of like a numbering system that can go up to infinity, as well as the circular nature, because we got a little bit deeper understanding of the octaves and how they work, and how therefore to properly visualize the notes, it wouldn't be a circle, it wouldn't be a line, it would be a spiraling kind of thing that has both linear increases and decreases in an infinite way, as well as repetitive areas. But we can't, as human beings, visualize that properly. No one can. It's not just me. It's not just you. We're not stupid. No, it's too complex to visualize things like that. Therefore, we're going to pick the task that we are doing and visualize it as either a line, a linear progression that goes out into infinity, or as a circle like a clock. And that will help us to achieve the task that we want to do musically, typically. Now, the other thing that we haven't touched on that we just kind of accept a priori when we do our mapping out of our music theory is the progression of the major scale and the related modes that it's built off of, which we just say is the formula. We have our 12 notes and we say there's a whole, half, whole, half, which we'll get into more later. But that is something that we're just going to accept. That's just the way it is. But we want to then dig a little bit deeper here and think about maybe why that is the way it is, as well as why different instruments sound different. And that's basically what we will get into here. Remembering that there's nothing wrong oftentimes when learning something to accept certain conditions a priori, meaning they're going to say that the music teacher says that's the formula, so that's the formula. I'm just going to apply out the formula. And I'm going to trust the system that there's some reason that they came up with that. But obviously at some point in time, we might want to question that or dive deeper into why did that come about. And that's appropriate to do as well, because that could lead you to different ideas on what you want to do with music later. So don't let the fact that you just accepted something because that's the way it happened traditionally stop you from at some point saying, well, why is that the way it happened? You don't need to question everything from the start, because that's going to take forever. You're going to try to rebuild everything from the start and question everything to a strong degree. But you do want to keep open the fact that I would like to know more about the things that I've accepted a priori in order to build on it from there. Okay, so the harmonic series. The harmonic series is a naturally occurring sequence of pitches produced when a single note called the fundamental vibrates. So we're going to imagine the noise is happening. It's coming from, we're going to imagine a guitar, the string of the guitar is plucking. We compare that to a rock that's dropping into a puddle of water. We note that when a rock drops into a puddle of water, we see waves. The waves we can often imagine as a sine wave, but in reality, we can imagine something more like a puddle of water. It's actually a wave that's going all the way around the puddle, right? It's emanating from that source to wherever it's not being blocked from emanating from that source. And it also doesn't have just one wave. It actually has one primary wave. You're going to say there's the big wave that's happening. That's the one I want to catch if I'm surfing out there, unless it's too big. But then it also has the littler waves that are going to be taking place. And so that's the nuance that we want to basically keep in mind here, the nuance of the littler waves that are happening. So when we recreate the noise, then electrically, it used to be that they weren't really good at taking all the harmonics, all the littler waves, because it gets somewhat complex and they differ on different instruments, although there's some symmetry or some consistency to it, as we will see. And that's why things used to sound more digital, and that's why AI has gotten a lot better at predicting these types of harmonics based on different instruments. All right, so it forms the physical and mathematical fundamental for pitch, tone, and tuning in Western music.